So, Warren Buffett's net worth is $84.5 billion.
Yeah.
And this is the statistic that just completely breaks the human brain, I think.
Yeah.
Of that massive fortune, 81.5 billion of it came after his 65th birthday.
Yeah, it's a staggering reality to confront when you actually hear it out loud.
It really is.
Because almost the entirety of his wealth, like the financial mountain that defines him as the greatest investor of our time, it materialized well after the age when, most people have permanently retired to the golf course.
Exactly. And that's exactly why we're doing this deep dive today. We have a really fascinating source text, an excerpt titled "O4 Confounding Compounding." And its explicit mission is to entirely rewire how you think about time, growth, and success. Because the author includes that Warren Buffett statistic right near the beginning and then follows it up with a line that I think serves as, well, basically the perfect thesis for this whole discussion. The quote is, "Our minds are not built to handle such absurdities."
And it truly is an absurdity, right? To our natural way of thinking, anyway. Our mission today is to figure out the actual mechanics behind that absurdity.
Yeah.
We're going to explore why you, me, and pretty much everyone else constantly underestimates what is actually possible when small things are allowed to accumulate over long periods of time.
Because on a surface level, when we look at an $84 billion fortune, our intuition just demands a corresponding, equally massive origin story.
Right. We want the big event.
Exactly. We expect a secret formula or some unparalleled stroke of genius or like some aggressive, high-risk maneuvering that no one else could pull off. We want the size of the cause to match the size of the effect.
Naturally, yeah.
But to understand why that intuition is just totally wrong and why our minds actively reject the math of compounding our source takes us on this really interesting detour away from Wall Street. We actually have to start by looking at the ground beneath our feet.
We have to look at ice, to be specific. To understand how an impossibly large result comes from an utterly invisible starting point, we have to trace the billion-year history of the Earth's ice ages.
Which is honestly a super humbling place to start, considering how long it took us to even realize those ice ages happened in the first place.
Oh, absolutely.
Like, the text points out that our scientific understanding of the Earth's history is surprisingly young. You have Isaac Newton calculating the precise gravitational movements of the stars and the planets in the late 1600s.
Centuries before we understood our own planet.
Yeah. Centuries before we understood the most basic fundamentals of our own planet's geological past.
That timeline always surprises people. But the reason behind it is, well, it's purely mechanical.
How so?
Because mapping the cosmos requires a telescope and an understanding of mathematics. You just got to look up, right?
Right.
But understanding how the Earth works over deep time requires looking down. And more specifically, drilling deep below the surface.
Yeah, that makes sense.
Yeah, the mechanical capability to extract deep core samples from rock and ancient ice-like, pulling up these cylinders of ice that act as literal atmospheric time machines. That is a relatively recent technological advancement.
So we were successfully tracking the orbits of distant planets long before we had the tools to figure out that our own planet used to be like a giant snowball.
Exactly. It wasn't until the 19th century that geologists finally reached a consensus that the Earth had, on multiple occasions, been entirely covered in miles-thick sheets of ice.
And the evidence just became too overwhelming for them to ignore, right?
Early geologists mapping the landscape just kept running into these undeniable physical anomalies. They were finding these massive house-sized boulders made of granite.
Just sitting there.
Yeah, just sitting in the middle of limestone valleys, hundreds of miles away from their geological origin points.
Glacial erratics. It's like a giant picked up a piece of a mountain and just dropped it in a random field.
Precisely. And beneath those boulders, they found entire rock beds that had been scarred with deep, uniform striations.
Like they were scraped.
Yeah, scraped down by some unimaginable weight dragging across them. And when they pieced these geographical anomalies together, they realized they weren't just looking at the aftermath of a single anomalous freeze. The geological record showed 5 distinct cyclical ice ages.
And here's where the historical context gets really interesting to me. Because the scientists of the 19th century reacted to this discovery using the exact same flawed intuition that we use when we look at Warren Buffett's bank account.
Yes.
They saw a massive apocalypse-level effect, the freezing of an entire planet, and they assumed there must have been a cataclysmic explosive cause.
They applied linear logic. They assumed that to freeze the planet, you needed an event of unprecedented destructive power.
And to be fair, their theories were incredibly well reasoned based on that assumption. Like some geologists hypothesized that massive tectonic shifts had violently uplifted entire mountain ranges.
Right, the shifting continents.
Yeah, and that these sudden new mountains had permanently altered global wind currents, blocking warm air from the poles.
And other scientists favored the idea that an icy world was actually Earth's default natural state.
Oh, interesting.
Yeah, they theorized that this frozen baseline was only occasionally interrupted by world-shattering volcanic eruptions.
So the volcanoes were warming things up?
Exactly. The idea was that supervolcanoes pumped enough ash and greenhouse gases into the atmosphere to temporarily warm the planet, and then once that gas dissipated, the ice just returned.
Which, I mean, makes perfect logical sense. If you find a boulder moved 500 miles or an entire continent carved down to the bedrock, you immediately assume a volcano or a shifting tectonic plate was responsible. You look for the bulldozer, you know?
You do. But there was a fatal flaw in all those explosive theories.
The cycle.
The cycle. They couldn't account for it. The sudden violent eruption of a supervolcano or the uplifting of a mountain range might explain one singular isolated ice age. But it completely fails to explain the rhythmic cyclical repetition of 5 distinct freezing and melting events over millions of years.
Right, because mountains don't just pop up and disappear on a regular schedule.
No, they don't. The cycle was the missing variable. And the person who finally solved that mystery in the early 1900s wasn't looking at tectonic plates or volcanoes at all.
You looked up.
He did. Milutin Milankovic, a Serbian scientist, looked back up at the sky. He studied the Earth's position relative to the other planets, the sun and the moon.
Okay.
And he discovered that the gentle, almost imperceptible gravitational pull of the sun and the moon slightly affects the Earth's motion.
Mm-hmm.
So over the course of tens of thousands of years, the Earth experiences this slight wobble in its axial tilt and a really subtle shift in the shape of its orbit.
The Milankovic cycle. So it's literally just a tiny gradual shift in the angle at which the Earth faces the sun.
That's all it is. That slight tilt means that during specific parts of this long gravitational cycle, each of the Earth's hemispheres receives just a fraction more or a fraction less solar radiation than they usually do.
Which is a brilliant deduction. But Milankovic's initial assumption about how that subtle tilt actually triggered the ice was still slightly off, right?
It was. He assumed that when the tilt reduced the solar radiation, it caused ravenous, brutal winters. Like winters so profoundly cold that they simply snap-froze the planet.
There's that linear thinking again. Defaulting to the dramatic cause, you want an ice age, you need a devastatingly cold winter.
Exactly. But it took a Russian meteorologist named Wladimir Koppen to dig deeper into Milankovic's orbital data and discover the crucial nuance. And this nuance, it changes everything about how we understand growth and accumulation.
This is the pivot point of the whole deep dive, I think.
Yeah.
Because Koppen realized it wasn't ravenous freezing winters that caused the ice age.
No.
The icy culprit was moderately cool summers.
Moderately cool summers. Let's trace the mechanics of this feedback loop slowly, because it is literally the foundational blueprint for exponential compounding.
Let's do it.
It all begins when a summer never quite gets warm enough to fully melt the previous winter's snow.
So like September rolls around and there is still a little bit of hard-packed snow hiding in the shady parts of the valleys or up at higher elevations. Just a totally unremarkable leftover layer.
Unremarkable. But that leftover layer changes the baseline for the next year. Because that ice base is already sitting there chilling the ground beneath it, it makes it significantly easier for new snow to accumulate the following winter.
Oh, because the ground is already cold.
Exactly. It isn't landing on warm, heat-absorbing dirt. It is landing on a freezing foundation, so it sticks immediately.
Right, so the snowpack gets a little bigger the second winter, which then increases the odds that an even larger patch will survive the following summer.
Yes.
You now have a perpetual snowpack, and then the acceleration kicks in through the albedo effect.
Right, the albedo effect, which is the phenomenon where lighter surfaces reflect more sunlight. Perpetual snow is bright white, so instead of the Earth absorbing the sun's warming rays, the snow reflects that solar radiation back into space.
So the snow itself actively exacerbates the cooling of the planet.
It creates its own weather, essentially, which guarantees even more snowfall the next winter, which reflects even more sunlight the next summer. The loop closes and starts feeding on itself.
Wow.
And within a few hundred years, which is, less than a microsecond in geological time, a localized seasonal snowpack compounds into a continental ice sheet covering half the globe.
And the exact same mechanism operates in reverse to end the ice age.
Exactly the same.
Mm-hmm.
A slight orbital tilt lets just a tiny fraction more sunlight in during the summer. That melts a fraction more of the winter snowpack. Less snow means more dark Earth is exposed, which absorbs more heat, which prevents more snow the next year.
The ice retreats on the exact same compounding curve that built it.
Mm.
You know, thinking about this purely in terms of everyday life, it reminds me of how clutter accumulates in a house.
Oh, that's a great comparison.
Right. Because it's like leaving a small stack of mail on the kitchen counter on a Monday. That's not a big deal. It's just a few envelopes. But subconsciously, because that space is already occupied by paper, it sort of gives you permission to toss a magazine on top of it on Tuesday.
Yeah, the baseline has changed.
Exactly. By Wednesday, it's the designated pile, so you add a few boxes.
Sure.
And you never made a conscious decision to ruin your kitchen counter, but the accumulation of the leftover became the foundation for the next deposit.
The accumulation of a leftover. There is a quote in the source material from glaciologist Gwen Schultz that perfectly encapsulates your mail analogy, but, on a planetary scale.
Here's the quote.
She wrote, "It is not necessarily the amount of snow that causes ice sheets, but the fact that snow, however little, lasts."
However little lasts. I love that. The size of the initial input is practically irrelevant.
Completely irrelevant.
The only thing that matters is the retention. So the big takeaway from the history of ice ages is that you do not need tremendous force to create tremendous results.
Yeah.
If a tiny bit of growth is retained and serves as the fuel for future growth, that small starting base will lead to results that just completely defy human logic.
Which forces us to ask a rather uncomfortable question about our own psychology, really.
Uh-oh.
Well, if the mechanics of compounding are really just about a leftover base accumulating over time, whether that's snow or junk mail, why does it continually catch us completely off guard? Like, why did early geologists invent imaginary volcanoes instead of just trusting the physics of the snow?
Because of a deeply ingrained glitch in our mental hardware. The source text notes that linear thinking is fundamentally intuitive to humans, while exponential thinking is entirely unnatural.
Yes.
And I actually want to demonstrate exactly what that cognitive friction feels like for the listener. So let's run a real-time math experiment based directly on the text.
All right, I will give you a calculation, and I want you to simply solve it in your head out loud. We will start with a linear calculation.
Okay, I'm ready.
What is 8 plus 8? Add it together 9 times in a row.
Okay, simple addition. 9 times 8, that's 72. It requires almost zero cognitive effort. It's immediate.
That is linear calculation. Now, let's switch to an exponential calculation using those exact same numbers.
Yeah.
I want you to calculate 8, multiplied by itself 9 times, 8 times 8 times 8, and so on.
Oh, boy. Okay, let's actually try to walk through this and see where my brain breaks.
Go for it.
8 times 8 is 64. 64 times 8 is 512. 512 times 8. All right, that's roughly 4,000.
Yeah.
4,000 times 8 is 32,000. 32,000 times 8 is roughly 250,000. 250,000 times 8 is 2 million.
Keep going.
2 million times 8 is 16 million. And 16 million times that final 8 is somewhere around 130 million.
The exact answer is 134,217,728.
Wow. Doing that out loud, you can physically feel the working memory in your brain tapping out.
Oh, absolutely.
Like, by the time I hit 32,000, it took immense focus just to hold the number in my head, let alone perform the next multiplication. It's exhausting.
And that exhaustion is biological. From an evolutionary standpoint, the human brain was never required to calculate exponential threats.
Right.
Our ancestors needed to know if there were 5 lions behind a tree or 10 lions. They didn't need to conceptualize an environment where the number of lions multiply by itself every hour. We are hardwired to comprehend addition, counting things one by one.
That makes total sense.
But when a growing base multiplies against itself, the numbers run away from us so violently that our internal logic simply shuts down.
We experience cognitive dissonance. We inherently underestimate what is possible. We underestimate where the growth comes from. And we drastically underestimate the final destination.
Exactly. And the author points out how this blind spot shows up in everyday personal finance. Consider those standard compound interest tables you see in retirement planning articles.
Oh, right. The ones comparing someone who starts saving $100 a month in their 20s versus someone who starts in their 30s.
Yes. Everyone looks at those charts, sees the multi-million-dollar difference at the end, and they say, wow, seeing that chart completely changed my life. But the author makes a brilliant observation here. He argues that those tables probably didn't actually change anyone's life.
Wait, really? Why not?
Because what those tables actually did was just surprise them. Because intuitively, when we look at the input, a meager $100 a month, the output of $3 million simply doesn't feel real.
It feels like a typo.
Yes, the linear brain rejects the exponential reality.
Think about how you, the listener, plan out your own life. When you map out a 5-year plan for your career, you likely think in straight, predictable, linear paths. If I put in 10 hours of work, I will get 10 hours of output. If I hit these 3 metrics, I will get this specific promotion. But compounding isn't a straight line. It is a curve that stays stubbornly flat for a very long time and then violently shoots into the stratosphere.
Violently.
We are all trying to navigate an inherently compounding world using a strictly linear brain.
And that mismatch between our linear expectations and the exponential reality is precisely why the smartest people on Wall Street completely misunderstood the most famous investor of our time.
Which brings us back to the Warren Buffett anomaly.
Exactly. Now that we understand the cognitive math glitch and we have the framework of the accumulating snowpack, we can actually decode his $84 billion fortune.
Yeah. The source mentions that there are over 2,000 books dedicated to detailing exactly how Warren Buffett built his wealth. Thousands of authors, analysts, and economists dissecting every trade he ever made.
And yet the vast majority of those books completely miss the fundamental architecture of his success.
How so?
Well, they dedicate hundreds of pages to his skill in identifying undervalued companies, his use of insurance float, his management style, but they ignore the most critical variable. His fortune isn't just the result of being a brilliant investor. It is the result of being a brilliant investor since he was a child.
Let's frame that with the staggering math we discussed at the beginning. So, as of the writing of this source, his net worth is $84.5 billion. $84.2 billion of that came after his 50th birthday.
Right.
And $81.5 billion came after his mid-60s.
It is the lingering snow.
It's pure, unadulterated accumulation. And to really illustrate how vital the timeline is, the text offers this brilliant alternative universe thought experiment.
I love this part.
It's so good, we know the reality. Buffett began serious investing when he was just 10 years old. By the time he reached age 30, he had already built a net worth of $1 million, which, adjusted for inflation, is roughly $9.3 million.
Which is a massive financial snowpack to have gathered by your 30th birthday. It provided an enormous base for the exponential curve to act upon. But let's alter the timeline. Let's pretend Warren Buffett was just a normal person.
Okay, so in this alternate universe, young Warren doesn't spend his adolescence reading financial statements. He spends his teens and his 20s exploring the world, trying different jobs, figuring out his passions.
Normal 20-something stuff.
Yeah. And by age 30, instead of $9 million, his net worth is a very respectable, completely normal $25,000.
Now, at age 30, he discovers his calling. He still possesses his exact, extraordinary investing acumen.
Okay.
He still achieves his legendary 22% annual return on his investments every single year, just like he did in reality.
So his intellectual skill level is exactly the same. He is still a financial genius.
Still a genius. But because he's a normal guy, let's assume he decides to quit investing and retire at age 60 to travel and spend time with his grandchildren. He stops the compounding engine at 60.
So he invests brilliantly for 30 years. 3 decades of genius-level 22% returns. What is his net worth today in this alternative timeline?
It is absolutely nowhere near $84.5 billion. In this scenario, his net worth today would be $11.9 million.
Well, wait, $11.9 million?
Yes.
That drop is staggering. You take away the first 20 years of early base building and you cut off the final decades of mature accumulation, but you retain the exact same level of genius, and his net worth drops by 99.9%.
Effectively, all of his financial success is tied inextricably to the financial base he built during puberty and the longevity he maintained into his geriatric years.
Wow.
The middle part, the actual 30 years of his career where he did the most visible work, is just the engine. But the fuel powering that engine is the time on either end.
As the text perfectly summarizes.
Yeah.
His skill is investing, but his secret weapon is time.
Yes.
And it makes you realize why none of those 2,000 books are titled, "This Guy Has Been Investing Consistently for 3/4 of a Century."
Right.
Because a title like that sounds incredibly boring to our linear brains.
It wouldn't sell a single copy.
We want the erupting volcano. We want a complex, secret stock-picking formula that we can memorize and apply tomorrow to get rich quickly. We don't want to hear that the ultimate secret to unprecedented wealth is just sitting in a chair and letting the snowpack sit undisturbed for 75 years. It feels completely passive.
Human beings have a deep-seated bias toward action. We want to do something to achieve success. We don't want to wait for success. And this impatience brings us to a really fascinating contrast.
Okay.
If time is genuinely the heaviest weight on the scale, what happens if someone is mathematically a far superior investor to Warren Buffett, but they just don't have the time?
Enter Jim Simons. For those unfamiliar, Jim Simons is a brilliant mathematician who founded the hedge fund Renaissance Technologies. They run the famous Medallion Fund. And when we look at pure investing acumen-like, the actual annualized rate of return generated on capital Simons is playing a completely different game than Buffett.
Oh, entirely. Since 1988, Simons has compounded money at an unprecedented 66% annually.
66%.
Annually. No one else on Earth has a track record that even approaches that number.
No. Okay.
To put it in perspective, Buffett's legendary rate of return is roughly 22%.
So Simons is generating returns 3 times as high as Warren Buffett year after year.
Yes.
So logically, if Buffett is worth $84 billion at 22% and Simons is tripling that efficiency at 66%, Simons should be the richest man in the history of the world by a massive margin.
He should be.
But as of the source's writing, Jim Simons' net worth is $21 billion.
He is 75% less rich than Buffett. And the reason why highlights the terrifying power of the exponent. Why is the superior investor significantly less wealthy? Because Jim Simons didn't find his investment stride until he was 50 years old.
He didn't start building the snowpack until half his life was over. Buffett started at 10, Simons started at 50. He has had less than half as many years to let the compounding curve accelerate.
Exactly. And to drive this point home, the expert in the text outlines a mathematical extrapolation that sounds like pure science fiction.
Let's hear it.
What if Jim Simons had earned his 66% annual return over the exact same 70-year time span that Buffett has had?
Oh, man. If he had started at 10 years old, maintaining that 66% return.
The text writes the number out completely, and it is almost comical to read. If Simons compounded at 66% for 70 years, he would be worth 63 quintillion, 900 quadrillion, 781 trillion, 780 billion, 748 million, $160,000.
That's just...
A quintillion is a 1 followed by 18 zeros.
Yeah, the author readily admits these are impractical, absurd numbers. 63 quintillion is a number reserved for astrophysics, not personal finance.
Right, it's physically impossible because there isn't $63 quintillion of total value in the entire global economy.
But the absurdity of the number is exactly what makes the point so profound. It mathematically proves how much latent power Simons sacrificed simply by starting later in life.
Small changes in growth assumptions, like jumping from a 22% return to a 66% return, when applied over a massive horizon of time, lead to realities that break the boundaries of physics and economics.
Wow.
But just like the early geologists looking for a sudden mountain range to explain the Ice Age, we constantly obsess over finding the highest rate of return, the 66%. And we completely ignore the longest period of time, the cool summer.
We obsess over the rate and we ignore the time. And this cognitive blind spot isn't just limited to geology and high finance. It affects how we interact with the modern world every single day.
Oh, entirely.
We've seen compounding shape the Earth's history, and we've seen it build billionaire bank accounts. But there is one area where every single person listening has literally watched exponential compounding happen right in their own living rooms, and yet we still constantly fail to predict it.
We are talking about computer storage.
Yes.
The history of the hard drive is perhaps the most perfect physical manifestation of the snowpack effect in human history.
I love this pivot because money and ice ages can feel a bit abstract, but everyone listening to this has a hard drive in their pocket or sitting on their desk right now.
Let's trace the historical timeline of IBM hard drives as outlined in our source. In the 1950s, IBM developed a hard drive that held 3.5 megabytes of data.
3.5 megabytes. Just to contextualize that for today, that is roughly the size of 1 single high-resolution photograph on your smartphone.
Right.
And the machine required to store that one photo was the size of a large commercial refrigerator. It used massive spinning magnetic drums.
Moving into the 1960s, the engineering improved slightly. Storage capacity crept up to a few dozen megabytes. By the 1970s, IBM released the Winchester drive, which held 70 megabytes.
So for the first 20 to 30 years, progress was incredibly slow and steady. We went from 3 megabytes to 70 megabytes. It was a purely linear progression, limited by the speed at which human mechanical engineers could physically refine the hardware.
Yes. And by the early 1990s, a typical personal computer in a home office held maybe 200 to 500 megabytes.
I vividly remember those computers. You had to aggressively manage every single file you saved. You couldn't install too many programs at once because storage was a precious, finite resource.
But then, as the text notes, wham!
Wow.
The base had finally gotten large enough. The compounding effect hit the steep, vertical part of the curve. Things exploded.
Why then, specifically?
Because the computational power of one generation of computers became robust enough to design the microchips of the next generation. The software began optimizing the hardware, creating accelerating feedback loop.
The snow began reflecting the sunlight. The system started feeding on itself. Let's look at the timeline immediately following that inflection point in the 90s. In 1999, Apple releases the iMac. It comes standard with a 6-gigabyte hard drive.
Which was a massive jump, from 500 megabytes to essentially 6,000 megabytes in the blink of an eye.
4 years later, in 2003, the Power Mac features 120 gigabytes. 3 years later, in 2006, 250 gigabytes on the new iMac. Fast forward just a few more years to 2011. The world sees the first 4 terabyte hard drive. 2017, 60 terabyte hard drives. And by 2019, 100 terabyte drives are available.
The author breaks down this timeline comparison brilliantly to really illustrate the exponential curve. From 1950 to 1990, a span of 40 years of intense human engineering, the world gained a total of 296 megabytes of practical storage capacity.
40 years of effort to gain less than 300 megabytes.
But from 1990 to 2019, a span of under 30 years, we gained 100 million megabytes.
100 million. Compared to 296, it is dizzying.
It is.
It is literally the 8 times 8 math experiment happening in physical reality.
If you were a tech optimist sitting in a lab in the 1950s, dreaming ambitiously about the future of computing, you might confidently predict that storage would eventually get 1,000 times larger.
Sure.
If you were considered a radical, borderline delusional visionary, you might guess 10,000 times larger.
Which would have sounded like absolute science fiction to your peers.
Exactly. But no one, absolutely no one, would have ever guessed that storage capacity would get 30 million times larger within a single human lifetime. It simply does not compute in a linear brain.
And what is truly terrifying is that this compounding curve doesn't just catch average linear thinking people by surprise. It blindsides the absolute geniuses who built the industry.
Yes.
The source highlights this incredible anecdote about Bill Gates in 2004.
Oh, the launch of Gmail.
Right. In 2004, Google launched Gmail, and they made waves by offering users a full gigabyte of free storage space. And Bill Gates, the founder of Microsoft, the man who arguably led the personal computing revolution, publicly criticized the move. He genuinely wondered why anyone would ever possibly need a full gigabyte of email storage.
Author Stephen Levy noted something really profound about Gates' reaction to Gmail. Levy wrote that despite Gates being intimately involved with cutting-edge technologies, his mental model was still anchored in the old paradigm of storage being a commodity that must be conserved.
Wow. He was still operating under the assumption of the 500 megabyte hard drive. His mind was anchored in a linear past, unable to visualize the exponential leap that was already happening around him.
Yeah?
And if Bill Gates, one of the foundational architects of the digital age, can get completely blindsided by the compounding of his own industry, what hope do the rest of us have?
Very little, honestly, if we continue to rely solely on our intuition. The text points out a crucial danger here. The danger isn't merely that we are bad at multiplying large numbers in our heads. The real danger is that because compounding feels so counterintuitive, we consistently ignore its potential.
Hmm.
We try to solve complex problems the hard way, through massive immediate interventions or exhausting effort, because we rarely stop to consider that simply waiting for a compounding process to unfold might do the heavy lifting for us.
We exhaust ourselves trying to build a volcano to melt the ice, when all we actually need is a cool summer.
That's exactly it.
Which brings us to the crux of our entire deep dive today. We have explored the geological history of the Earth, we've broken down our cognitive math glitch, we've analyzed the timelines of the world's greatest fortunes, and we've tracked the evolution of the hard drive in your computer.
A pretty wild journey.
Yeah. So how do you, the listener, actually apply this knowledge to your own life without getting discouraged by the sheer scale of the math? What is the actionable strategy when time is the secret ingredient?
Well, the most practical takeaway outlined in the source is realizing that the counterintuitive nature of compounding is the root cause of the majority of our bad strategies, our disappointing trades, and our failed attempts at building long-term success.
Because we are always chasing the wrong metric.
Exactly. It intuitively feels like trying to earn the absolute highest returns possible. Chasing that 66% like Jim Simons from day one is the smartest way to get ahead. People devote all their energy, all their education, and all their daily effort to chasing those extreme, anomalous peaks of performance.
They want the viral moment. They want the lottery ticket stock, the overnight success, the one massive project that will instantly catapult them to the finish line.
But the trap is that the highest returns in life, whether in finance or in our careers, tend to be one-off hits.
Right.
They are unsustainable anomalies. And more importantly, achieving those extreme peaks usually requires taking on extreme risk, which means they cannot be repeated consistently over time. The text explicitly warns that earning huge returns that cannot be held on to almost always leads to tragic stories.
Because you wipe out.
Exactly, because if you take a massive risk to secure a huge return, eventually the mathematics of that same risk profile will wipe you out. The snow melts.
The snow melts, you lose your base, and without the baseline, you have absolutely nothing left to compound. You're back to zero, forced to start over with a linear addition.
Precisely. True. Effective compounding, and this applies to investing money, investing your time, or investing your energy, isn't about achieving the absolute highest return in a single isolated year. It is about earning pretty good returns that you can actually stick with. Returns that are sustainable, manageable, and can be repeated for the longest possible uninterrupted period of time. That unbroken chain of survival is when the math of compounding runs wild.
It's the moderately cool summer. It is not about surviving a freezing, devastating, apocalyptic winter. It is simply about maintaining a climate just cool enough to let the snow survive. You just need to ensure that your progress survives to the next year with your base completely intact.
The author notes that there are thousands of complex books written on cyclical economic theory, advanced day trading strategies, and highly specific sector bets.
Right.
But he argues that the most powerful finance book in the world shouldn't be a massive, complex textbook. It should just be a single page featuring a long-term chart of global economic growth. And the title of that one-page book should be Shut Up and Wait.
Shut up and wait. I love that. It is blunt, it is aggressive, but it is exactly the medicine our linear brains need to hear. I want to translate this directly for the listener's daily mindset right now.
Please do.
We cannot blame ourselves for instinctively wanting the biggest, fastest return. It is literally our biological nature. We evolved to react to immediate stimuli, not 70-year time horizons. But the real strategy, the true cheat code to the universe that we have uncovered today is prioritizing consistency over intensity.
Consistency over intensity. If you remember nothing else from this discussion, remember that phrase.
It is not about the heroic, exhausting, superhuman effort of one single day. It is about making sure your progress, however small, however unglamorous, survives to the next day.
Yeah.
It's about not wiping out. It's about letting little bits of snow stick around so they can quietly become the foundation for tomorrow.
Synthesizing our entire journey today, we have traveled from the cyclical, icy freezing of the globe to a mind-bending multiplication problem that exhausts our working memory, through the chronological timeline of the world's most famous billionaire, to the literal hard drive storing the audio of this conversation right now.
Yeah.
And the underlying inescapable current connecting every single one of those seemingly unrelated phenomena is the silent, staggering, invisible power of compounding time.
It is the skyscraper building itself in the dark. You don't see the cranes, you don't hear the jackhammers, but you wake up one day and the building is suddenly touching the clouds.
That's a great way to put it.
As we wrap up this deep dive, I want to leave you, the listener, with a final thought to mull over. We have spent this entire time talking about the shut up and wait strategy, strictly in terms of financial wealth, scientific history, and technological gigabytes. But what if we applied this exact same framework to the rest of our lives?
Extending the math into the deeply human application.
Yes. Think about the process of learning a new language. Think about the energy required to build a deep, resilient friendship, or the discipline needed to master a complex new skill like playing an instrument or writing a book.
Mm.
What are the moderately cool summers in your daily habits? What are the small, unglamorous, completely sustainable efforts that you are making right now that you might be tempted to prematurely abandon because you are frustrated that you haven't seen an eruption of explosive success yet?
It is a vital question to ask ourselves.
Mm.
We quit our endeavors because we expect the sudden mountain range, and in our impatience, we ignore the snowflakes.
Exactly. Maybe the key to your next big breakthrough isn't trying harder. It isn't finding a radically new strategy, or taking a massive risk, or summoning an apocalypse-level effort to force a result. Maybe, just maybe, the true secret is simply sticking around long enough to let the snow stick.
Thank you so much for joining us on this deep dive into the confounding invisible nature of compounding.
We hope we've rewired your brain just a little bit today. Embrace the wait, protect your snowpack, and we will see you next time.